Hello again folks. In this video we're going to be taking a look at this Rotary Persistence Division clock kit that Graham kindly sent in to me. So we're going to take a look at the components, talk about how it works and start building the thing. So this is probably going to be part one of possibly two, maybe three videos. I want to keep this video as short as possible. To do a complete kit build would probably take about half an hour or so. So yeah, we'll split it down. But yeah, let's have a look at the components. So I'm not going to take you through everything, just the key things, and talk about how that's going to work, within the kit as we go along. So clearly we've got an enclosure here. It's a repurposed enclosure. We can see there's provision for battery terminals here, and there's a speaker grill, and the actual holes look like they have been hand drilled by the manufacturer. Point to note, I did look everywhere on Tinternet and cannot find any instructions on this at all. Graham said he couldn't find any instructions. The listing on eBay where he bought it from did have some vague instructions, but absolutely nowhere near the detail that you'd need to construct this. So I am in essence kind of winging this, but I think I've worked out where everything goes. But yeah, so the main components, obviously we've got a DC motor there, which is going to spin this rotor arm, or propeller. They're sometimes called propeller clocks. So it's going to rotate that. And the only other real interesting things are the two coils and the power supply board. So at this point I'll say that the actual rotor arm itself is not electrically connected in any way to the base unit, if you like. This small board forms a power supply, and that power supply powers the DC motor, the larger coil, and a small infrared LED. The smaller coil will be attached to the board. Now, if we look at the underside of the rotor arm, you can see that this has possibly been repurposed as well. It looks like you could have a spring contacts get onto the board to transfer power, but this board is entirely powered from this small coil. So we have, much in the same way as modern mobile phones do the wireless charging, we've got two coils that are inside one another, and the larger coil is powered by this board, which generates an inductive, it's an inductive transfer of power to the smaller coil, and that basically makes the board work. The various circuitry on here, we've got a couple of shift registers, a little EEPROM sorry, and a small microcontroller. And basically, let's say that the board is powered totally using these coils, so it's not electrically connected, and these components on here are doing all the magic, so that the persistence division effect does work. I mentioned an infrared LED. We do have that infrared LED that is attached to the board, and we have a photodiode in here somewhere. There we go. Photodiode gets mounted on here with the small lens just protruding through the hole on the PCB there. So if I flip it over, you should just see the lens in there like that. And essentially what happens is this is mounted on the DC motor, which is spinning round like so. Power's being transferred via the coils, as I've already mentioned. The infrared LED is being detected by that photodiode, and that is basically the trigger for the effect to work, so that it's turning on at the same point every time, on every rotation. When it detects that infrared LED, the circuit will essentially activate, and that persistence division effect becomes apparent. And that's when we can see that the actual text or numerals on the clock being sequenced by these shift registers. So hopefully that kind of made sense. But what I thought would do in part one of the build is do the surface mount components, because I thought it would be a really good opportunity just to recap the various techniques we can use to solder surface mount components. So we're going to have a go at using solder paste, we're going to have a go at drag soldering, and we're going to have a go at dabbing, just dabbing solder onto each contact on these packages here. So without further ado, I'll pause the video and we'll get set up to start the surface mount soldering. So just bear with me, I'll catch you in a moment. Okay, welcome back. Right, so the first technique we're going to do, I think, is just using hot air. And we're going to put these small 104 capacitors on. There is 6 passive components to go on here in terms of surface mount devices. We've got 3 104 caps there. We've got a 10k resistor, that's a 103, which is correct. So you 10 for 10 and then 3 zeros, giving you 10k. And we've got the 2 20 picofarad capacitors on this side as well. So I haven't measured these out or metered them out. I've purely just worked out, hopefully, that they have included the correct values, and we'll just go with that. I don't see why it wouldn't be the right values, but yeah, we'll give it a go and see how it works. So let's crack on. So we'll get the board positioned. I'm also going to be using the tweezers that Graham sent in because I can't find my other one. So again, thank you very much, Graham. Very generous of you. So we'll just peel the, sorry, I don't know if you can see that there. We'll just peel the backing tape off and tip these out. And we'll get our solder paste. So remember, less is more when it comes to using solder paste. Good technique, if you can see this okay, is to put the needle directly onto the pad and just the very tiniest of, very tiny amount of solder paste required. Like so. And I'll do this side. And this side, as I said in previous videos, it doesn't matter if you get a little bit of, what you might anticipate to be shorting of the contacts with the solder paste. The surface tension will sort that out for you. So we'll just lift the components, drop them roughly in position on the board, and then we'll get our heat gun on the go. So I'm using I think it's a clone, to be honest, but I'm using the Aten or Aten 858D+. I'll just check the temperature. So it's set to 370, which should be more than enough, and it's a 3 when it comes to the airflow. And all we're going to do, so I'm just bumping the camera there, is gently heat up the solder paste. You will see that change into a putty sort of grey colour, and then it will just melt and flow into the flow the components onto the pads. Flow the solder onto the pads and drag in the component and lock it in using surface tension. So there, it's changing colour, so we're not far away from it reflowing. Try and get it from this side now. There we go. It's getting dragged into position, and that doesn't look too bad. Maybe just a little tap with the tweezers, if I can find them. Yeah, we'll touch that one up in a little while. I don't know why it's not working there. So again, just apply heat. Always keep your airflow moving. Don't want to keep it in the same position for any great length of time. I think possibly this metal plate may be wicking some of the heat away as well, which might not be helping. There we go, that one flowed nicely. And finally, I'll just lift this up actually, see if it makes a difference. Yeah, straight away you saw that just popping into place, hopefully. Let's just try this one again. There we go. Hopefully you saw that. Apologies if you didn't. So there we go. Nice fillets on the... just try and get that to focus. Yeah, nice fillets on the components. No problems at all with those three. There we go. So apologies that took a little bit longer than I had anticipated. So the next thing I think we'll try is... what will we do? We'll try a bit of drag soldering, I think. So, I've got my iron warming up. And I'll get my fine solder. I'm using Loctite multi-core. This is 0.7mm. And we'll do this, we'll do the shift register. In fact, no, we'll do the microcontroller. So what I'm going to do is tin one of the pads. And then we'll grab our tweezers. Check the orientation of the chip. So, I don't know if you can see that there. Get it to focus. We've got a little dot here. That is pin 1, and that goes to the notch. Now this was taped onto the board and it is a little bit sticky, so here we go. So we'll just heat up that solder we just put on the board and check the orientation. So it's not too bad, it needs to come down a little bit I think. So again we'll just heat that up. Bring it down slightly, and that doesn't look too bad. Maybe a little tweak on there. Yeah, not too bad at all. And we'll attach the other, or the opposite pin. A little touch of solder on there, like so. Right, it's at this point you need to get your flux pen. And all flux does is it cleans the components, legs, and the PCB pads as well, and just makes your solder flow just that little bit easier. So a little bit, don't want to be using too much. And what we're going to do is apply a little blob of solder onto our tip, and then just simply drag it down those pads, and it will flow into each of those. It'll flow into the pads, and then gives a nice electrical connection. So, just like so. Maybe a touch more. I should really be using a larger tip than this. But we'll work with what we've got just now. Flip it round. A little blob of solder, drag it down a little bit more. A couple of shots here, which we can try and use the tip just to remove that. There we go, and that's it. So we'll have a little inspection. This isn't going to be perfect. It's been a while since I've done this, but I'll get it to focus. Yeah, we've got a little shot there. Possibly need a little bit of solder on that end pin there. Yeah, definitely. Just try and remedy that while we've got it in focus. So there we go. That one gone. Okay, this side not too bad. Probably need some solder just on this pad here. And yeah, we'll do that now. So I'm just going to apply a little bit more flux. like so. Tiny amount of solder to the tip of the iron. We'll bring it back up into focus. Where did we say we needed? Yeah, this one here, wasn't it? Flip it around this way. And this end pin, yeah, definitely needs some solder on. So there we have it. Not perfect, but good electrical connections, it would appear. No problems with that at all. Right, okie dokes. Next thing I'm going to do is stick on these shift registers, and we'll just do that in a similar fashion as the touch-ups we just did there. So tip those out. Again, we're going to want to check the orientation, and then we've got our dot on there, which is pin 1. So these are going like so. Just apply a little bit of solder onto the pin, the pad, sorry. Lift the component in, reflow that solder, a little bit of minor adjustment. That'll do. And we'll take the next one and just repeat that process. There we go. So not too bad in terms of orientation. They look good, or alignment I should say, rather than orientation. So just apply a little bit of solder to the opposite pin, and that will just keep it nice and steady on the board, like so. Apply some flux, and yeah, we'll just apply solder in much the same way as we did before. So we're going to turn the iron very, very lightly, and then just touch each pad in turn. And that flux is going to help draw that solder into the pads and the leads and make a good electrical connection. Okay, so I'll just do that one side, and then what I think I'll do now is I'll just get it to focus. There we go. So again, not perfect, but good electrical connections. So what I'll do, yeah, I'll pause the video. I'll do the rest of these, put this EEPROM on, and then we'll come back and do the LEDs. So bear with me. I'll be back in a second. Hello again, folks. Right, excuse me. That's all the surface mount packages on there now. Relatively good soldering. I'm relatively happy with them. All look pretty good. No problems there. So what I'll do is, I just wanted to show you that board before I started messing around on this side. So what I'll do is I will pause the video. I'm going to paste all these up, and we'll come back and reflow them in one go. Just one point before I do that is we'll talk about the polarity of surface mount LEDs. So if I just grab these out, if we can. There we go. So if you note on here, I can get it to focus. You can see we've got a green side on here, and if I just flip it over, we can see we've got a sort of green T shape. Now the the flat line going along the sort of narrow, you know, how to explain this? This flat line that's vertical, if you like, as you see it on screen, that is the anode, and the smaller horizontal line, as you look at it, that points towards the cathode. So anode on the right, cathode on the left, and that is, if I just flip it over, the green you can see on there is the negative side. So yeah, I'll paste it up and then put these components on, and then we'll come back and reflow it. So again, thanks for bearing with me. Hello again, folks. Right, welcome back to hopefully the final part of this video. I appreciate it's over 20 minutes long now, but yeah, I've pasted this up. I've put these two caps and the resistor on this end, and as you can see, I've pasted this up, and I have put the LEDs on in a sort of rough alignment. So we'll just go ahead, get our heat gun again, and reflow these LEDs. So a good technique if if you've got a long strip of components, or a long line of components, is just to run up and down evenly. That means that all the components and the paste below them are going to be heated up at the same time. It's not going to stress the board too much, and yeah, it should give us quite a neat job. So always have a set of tweezers handy at this point as well, just in case anything decides to fly off or need to be knocked into alignment slightly. But yeah, we'll just heat this up, and hopefully it should reflow soon, as it's just changed colour. There we go, start to go there, getting dragged into place. And that doesn't look too bad. Yeah, that should do the job. So there we have it. Let's let it cool off a second. Yeah, not too bad in terms of alignment. Maybe a couple needing a little bit of tweaking, which I'll do after the video. But yeah, there we have it. So we'll call that the end of part one. Again, apologies it's so long, but there you have it. I just thought it'd be an ideal little opportunity to showcase those various surface mount soldering techniques. So if you enjoyed this video, give me a thumbs up. If you didn't, give me the thumbs down. Click on my fat head, wherever it is here, to subscribe if you haven't already done so, and I hope to see you again soon for part two. Until then, take care of yourselves, and as always, all the best.